Hi guys, I'm having to record this again because apparently I'm not having good luck today on recording stuff. But anyway, let's go through it and see what I can help you out with here. In this particular video, I'm going to walk through how to do a chi-square um, association test, and I'm going to go through your assignment. So our first example is the walkthrough, and it's going to be regarding Narcotics Anonymous, and I have a data set in there that you can download. So again, chi-square walkthrough, how to calculate it using Jamovi. So our scenario is this: a group of researchers want to study the relationship between participation in NA, Narcotics Anonymous, and employment status among a group of individuals who've completed a substance abuse recovery program. So they've been out of recovery for 6 months, and we're looking at employment data. So we're looking at 200 individuals 6 months post treatment. We have Narcotics Anonymous participation. Are they attending Narcotics Anonymous or NA meetings? They can either attend or not attend, and then employment status. So they're either employed full-time, employed part-time, or not employed at all. So basically, we want to know if attending NA is associated with employment. So I just said that right there. We're going to use a chi-square test of independence to analyze our data. And I'll explain this on the next slide. This was just a graphical way of looking at it. So individuals 6 months post-treatment participated in A or did not participate. Are they employed full-time, part-time, unemployed, full-time, part-time, unemployed? Our hypotheses, null is there's no association. So attending NA did not affect or had no association with their employment status. Alternative hypothesis, there was an association between their participation in NA and their employment status. And again, I told you the data set is in Canvas. So if you want to pause the video right now and go open up your data set, you're welcome to do that. So I've recorded this like 3 times, and my microphone has cut out, as in it has died. It's a Bluetooth microphone. So this is the 3rd time, perhaps 3rd time's a charm. So I'm going to open up my data set, which is my Narcotics Anonymous data set. My variables, I have NA participation. They can either attend or not attend, and then I have employment, and it has 3 levels. These are all nominal. Remember, employed part-time, full-time, and then unemployed. So what I'm going to do is go to frequencies, then independent samples, which you'll see underneath there. It's got the X that stands for chi, so chi-squared test of association. I'm going to move NA participation to rows and employment status to columns. There's nothing that needs to go under counts or layers. I'm going to go to statistics and make sure chi-square is selected. I am technically looking at whether or not attended NA is greater than this second, the non-attendance, but for now I'm just going to leave it as this, a two-tailed, just because I'm curious. I could go back and run. I'm going to do that in a minute. We'll go back and run it the other way and see if there's a difference. And I want to hit phi and Kramer's. It's actually going to be the Kramer's V, I think that's going to give me the data that I need to interpret the significance of the effect. Not the significance, the effect, the size of the effect, if there is an effect. And then I want to make sure under cells, I have observed and expected, because in the assignment that you're going to do, it is going to specifically ask for observed and expected. And you don't have to do anything with percentages. That would just calculate some extra stuff out there showing you the percentages, but we don't need to know that at this point. So now we have a beautiful output over here. I have my expected full-time NA participants. I should have seen about 31, and I saw 40. For part-time, it's about what I expected. And then for unemployed, I have 17 that I should have seen if there was no association, but I only saw 8. So this is lending me to believe that there's going to be an association between these variables. So I'm going to look at did not attend NA. I have 9 observed and 18 expected. So that's telling me that something is off here. There, I expected to see 18, and I'm seeing a lot less than I should have. Under employed part-time, I'm seeing about what I should expect, but under unemployed, I'm seeing a whole lot more observed than the 10 that I should have. So now I need to interpret my chi-square test down here. Oops, did not mean for that to do that. So I have a chi-square of 20.2 with 2 degrees of freedom and an n of 100. And that is significant according to this. If you notice on this particular statistic, Jamovi does not star or flag significance, so you have to interpret that yourself. Remember, our significance is if anything and that p-value is less than 0.05, it is significant. Our p-value is less than 0.001, so it is definitely significant. So how do you interpret that significance as far as effect size? You go down here and look at Kramer's V, and a Kramer's V of 0.449 is a moderately strong association. And I included a chart over on the next slide when we get back to the presentation that you can use for interpreting effect size in the future. So let's go back and clear this. I want to keep this here, but let's go back and look at our data and look at, I want this to move. There we go. I want to go back and run this again with our one tail hypothesis. It's still going to be significant, but I'm going to leave these variables right here. And I'm going to leave that as well because that's not going to change. But under statistics here, if group 1 is my attended NA and group 2 is my did not attend NA, and I'm looking at one tail, I would be expecting a significant increase in the number of participants that attended NA that are full-time. And I did see that. But let's look at how reducing that probability in those two tails, if it does anything. It's probably not in this scenario because this is very significant to begin with. But if I do that, it's giving me my difference, and it's the same. You can tell here it didn't change. My value is 20.2. But sometimes you could see when you get certain data sets, you could see that by changing from a one-tailed to a two-tailed, you might miss an effect size. You might miss a statistically significant association if you're testing at the two-tailed level. So that's what's important to make sure that you are looking at the direction of your test. So I'm going to end this here and go back to the PowerPoint and then explain your assignment for the week. All right, so this is the slide that I told you I was going to include that interprets effect size for chi-square Kramer's V. We had a Kramer's V of 0.449. That helps us understand how strong the relationship is. It is between 0.30 and 0.5, so 0.449 is a moderately strong relationship. And that's good. That's what you want to see. So let's go over your chi-square assignment for the week. All right, for your assignment this week, you have the chi-square assignment document. You can download that. It opens up in Word, and it says you're analyzing health and lifestyle behaviors among 200 university students using survey data. This is building off of the test, the example from our notes, right? So 200 university students answered some survey data, and all the variables are categorical, so it's set up for a chi-square test. You want to explore the variables of gender, plans to get a physical, exercise frequency, health insurance, and major. So we're building upon variables that might be associated with getting that physical. So the first one is gender and plans to get physical, which is kind of similar to what we did in the example in the lecture. But then you're going to look at exercise frequency versus plans to get a physical. And so the idea behind that question is perhaps people who are concerned about their body, their health, are going to be more likely to get a physical because they're concerned, so they do exercise. The other one is a very pertinent one to this day and age is health insurance versus plans to get a physical. So perhaps if you don't have health insurance, you're not going to have a plan to get a physical. So you're going to explore these. I'm going to walk you through how you would do the first one and what you were going to put in here. So it says to run a chi-square test of independence between gender and plans to get a physical. So let's do that real quick. So I have my database here and I have gender and plans to get a physical. So I'm going to go to frequencies, independent samples, chi-square test of association. I'm going to put gender and then plans to get a physical. I need to go under statistics and make sure that this is here. The chi-square is picked. You can just keep it with the hypothesis of group 1 does not equal group 2. That's completely fine. You can click the Kramers if you want, just to see out of curiosity if it gives you anything else, but you do need to go under cells and click expected counts because that is part of the output. So let me see if I can split screen this. And it is I did not want to do that. All right, it doesn't want to help me out with that, so I'm just going to zoom out a little bit here. It says to write your null and your alternative hypotheses there. You should be able to do that. You're basically stating, is there an association or is there not an association? The next one says to report the observed and expected counts by pasting the contingency table. So you're going to snip that. Remember, your snipping is to do the Windows Shift S and it opens up that thing. You're going to do this and then you're going to go over here and basically just paste that right there. And then under here, it says paste the results of the chi-square table. You would take that table right there and you would paste that there. And then you would interpret the results. And if you look at this, this is not significant. So if it was significant, you would go down here for Kramer's V and you would tell me how strong that relationship is. And remember, the slide to be able to tell you about that is in this presentation. So I'm going to close this because I don't need to save all that right now. And I don't need to save this right here. That data set is in Canvas. And then the data set for the unemployment and NA example at the beginning of this presentation is also going to be in assignments down there. So you can see it if you want to run it yourself.